start recording. Hi, YouTube Lab. Let me share. And so I'll do third periods.
Got it.
How many people are, yeah, we'll just start with third. Well, I'll do third if you can do first and second.
Yeah.
All right. Yeah, I know. So yeah, it's really nice to see like so many people. Like I feel like, you know, a little bit of anxiety. You guys, like so many people are here today.
Oh, you did do first period. Question 9.
Oh my
Slide 10.
Oh, they did it. Okay, so then
it must have been second period we didn't get to. Oh, you did.
Or then we just didn't do third. Okay, whatever. We'll just start right here.
Yeah.
So we're gonna start on page 10. So for first and second, and again, we did cover it, but it was so quickly that you probably don't remember it. We're gonna still do the, hey, we're gonna give you guys time in like during the tutoring to be able to work on your version. But obviously we have let's see, 6, 7 people here, 8 people now. That it's not going to be, it's not gonna, like, we won't put a timer or anything on there. Well, I guess I will, and then we'll pause. So YouTube, you won't be seeing the pause. So whenever you see like I'm cutting in and out, it's because they're working on theirs, and then we'll go back. So again, everything, if you guys can't stay for the entire thing, don't feel bad. Everything will be recorded. We're gonna start on page 10. So first and second period, you've already done this one, but I went too fast. So we're gonna do this part. So reading the directions, it says the data table below represents a linear function. Since it says linear, we know that we're dealing with either a adding or a subtraction problem. And then I just have to say, is it a true or false statement? Well, looking at this, I can look at my numbers. It's 9, 15, 21, 33. My numbers are increasing. Since we are increasing, I know I'm going to be adding whatever my pattern is going to be. So I know I'm going to go from 9 to 15. That's going to be some sort of adding number. And then 15 to 21 is going to be adding. And then even though we have this 10, I'm going to pretend that this isn't here. Now, this is the mistake, and I made this mistake. No worries. I made this mistake in first period, and I totally botched it. And then I kind of fixed it in second period, but I want to make sure you guys get this. If we look at our last page, we had a very nice teacher make this table for us. It says 0, 1, 2, and 3. This is a nice teacher. Like Ms. Gomez probably did this. And then here comes Doc, and all of a sudden she wants to mess it up our whole plan and realizes that I have 0, 2, 4, 6. It's not by ones. This is by twos. All right. So our pattern by 2 will be different than our pattern by ones. So we can find the pattern for 2, and then we can do something to it to find the pattern for 1. So again, I don't know, like, let's pretend that this 10 doesn't, because that's like 4 pieces and that messes up with everything. So I don't have to worry about the 10. So let's find this pattern by 2s. So 9 to 15, what is that? That's going to give me 6. 9 plus 6 gives me 15. Double check and make sure if that's true. 9 plus what gives you 21? Well, 6. 9 plus 6, 21. Perfect. So we know that by 2, my pattern is 6. But I want it by 1 so that I can find out what my rate of change is, because I need to figure out what my rate of change is. All right. So how can I figure that out? I'm going to take this 6 and I'm going to divide this by 2 2 goes into 6 how many times? 3. So then I can find, so then I know my rate of change is 3. So I look at here at B, my rate of change of this function is 6. It is not 6 because we figured out it was 3. It was 6 if I went by 2s, and we don't care about going by 2s. So we know that this is going to be false. We can even do C. The function has a positive rate of change. We already know that because we see that positive. So this is true. Now we need to figure out our initial value. Is that 1? And if the equation is like this. So since it's still by 2s, we can actually still follow this pattern. And instead of doing plus 6, we can do minus 6 and figure out what this is. Or we could do like extend our table. And we know that 2 is 9. I can subtract 3. And then that would give me 6. And then subtract 3 again. And then that would give me 3. Or 9 minus 6 gives me 3. So you can either choose to just follow this pattern or expand your table and do the work on the side and do it like this. Whichever way you guys feel more comfortable with. So our initial rate is 3. So this says our y-intercept is 1. Is that true? No. Our y-intercept is at 3. So right here is where we're going to put our equation. So what's our equation? We have y equals, what's our slope? Our slope is 3. So 3x. What's our y-intercept? Our y-intercept is at 3, so plus 3. So is it true that the equation is y equals 3x plus 3? Yes. All right. So this part right here, having to go backwards, is probably the actually figuring out that it's not 6, that it's 3. That is the hardest piece because we're used to seeing tables like this from nice teachers, not like this, like, you know, Doc being super mean. And it wasn't me. It was, you know, the people creating the test, which I don't create the test. But that's our version of it. So for those of you guys who were in periods 1 and 2, this probably looks a little bit cleaner than what you guys, what we did, just because this is not the 3rd time that I've done it now. So it looks a little bit, you know, less crazy. But I'm gonna pause the recording. Let me resume the recording. So again, I'm seeing a lot of you guys are saying this is +8, but a lot of you guys are writing that this is true, but this is not true. Remember what I did? Remember, yes, this was like our rate of change would be 6 if I was going by 2s, but I'm not going by 2s. I need to go by 1s. So I need to take this 6, same thing as this 8, and we need to divide it by 2. So we should have, and I'll do it down here because you shouldn't have anything. So 8 divided by 2. What's 8 divided by 2? 4. 4 would be our slope. And I just realized that someone has work right there. So over here. 8 divided by 2 equals 4. So this would be your slope. So does that make sense? Does anyone have any questions on this one? How do you do the last part for this one? Like this bottom part? So once I know that my slope is 4, I can write, yeah, I can write, and again, I won't put it here. I'll put it down on the bottom. I know my equation needs to look like this. Y equals mx plus b. So y equals, m is my slope. This is slope. That's a horrible way of writing slope. Oh. So what's my slope? My slope is 4. It's not 8. It's 4. Because we want the slope 4 when we go by ones. And that's a horrible x. Why can't it turn to an exponential? If I divide it? We're not, what? Oh, this part you mean? When the pattern is not dividing. This is just me cutting the distance in half. So I'm saying, like, if I have, you know, like pretend this is a number line. This is at 2, this is at 4, this is at, you know, 6. So I am saying that from 2 to 4, my distance is 6, but I need to have the distance of 3 first. So what would be from 2 to 3? It would be 3. Remember, when it comes to slopes, that's like that picture perfect activity that we did, where we're figuring out the distance between each picture frame. The y-intercept is going to be the length of that the door that we took. So that's the reason why it doesn't become exponential. And then when I'm doing, then for my equation, I need to figure out what my b is. So I'm going to look here. The distance here is 2. So I could just use this same pattern and subtract by 8. Just do the opposite. All right. So what's 10 minus 8? 10 minus 8 is 2. So this right here should be 2. All right. I'm going to erase it because most of you guys had that. So down here, I would put 2. So my equation is all of this right here. Y equals 4x plus 2. Now, the only reason why the only time this wouldn't work is if this was not by 2. If from 2 to 0 was bigger than 2 or smaller than 2, then you would have to use a -4. So you would have to take 4 and subtract 4 and subtract 4, then subtract 4 until you get to that spot. But on your test, it'll just be like this. Your x's will be the same. It's just the y's that are going to be different. All great questions. Is there any more questions that you guys have, or do you guys feel better about this? So thumbs up, we feel good. Or either unmute yourself or give me a question in chat. How do you guys feel? All right. Then Ms. Gomez, since you're doing all of like first and second period, do you just want to keep doing that and I'll do these?
Yeah, okay.
That way you're not having to go back and forth between 10,000 different ones.
Okay.
All right. Okay. So question 10. The page 11 is going to be for me to do, and question 12 is going to be for you guys to do. All right. So so on page 11, I'm going to do this one. It says the total cost of an order of coffee cups from a company consists of the cost of each cup plus a one-time fee, design fee. The cost of each cup is the same regardless of how many cups are ordered. The company provides the following example to customers to help them estimate the total cost of an order of cups. So all of this, if you're like, what did it just say? Totally fine. This doesn't matter. Ish. All right. It just sets up it sets up the scene. What really matters is this table right here, or like this graph right here. All right. So this information and even this information is already put into this line right here. So for 10 cups, it costs $60. So at 10, it's at 60. For 40 cups, it's $210. So for 40 cups, if you go all the way up, it's 210. So it wants us to figure out A, what is the slope of the line in the graph? All right. Now you could want to like count how many to go all the way up and how many to go over. However, that's a very long slope and it's not the easiest slope to find. What I could do though is find my slope from my y-axis and use that first point that we got. Or I would keep going, keep going, keep going. I have this point right here. Keep going, keep going, keep going. I have this point right here. And then obviously that last point. Okay. So any of these points we can use. Now, notice here, it's going by tens. So instead of saying 1, 2, 3, 4, when we're counting, we'll count 10, 20, 30, 40, 50. And we're going up. So this is plus 50. All right. So when we have slope, we do rise over run. Rise, run. So our rise is 50. Then I'm going to do it in a different color. Let's do red. And I'm going to see that I have one jump. What's my jumps down here? It's also by tens. And this is to the right, so it's another positive. It's by 10. So over 10. But I can simplify this. How many times does 10 go into 50? 5 times. Okay. So far, thumbs up, we're all good. Anyone confused? Okay, cool. So let's look at question 2. So our B, what is the cost of the one-time design fee? Because we don't start at 0. As soon as I decide to order something from them, it's going, I have to pay one fee one time. So I can find out what that one-time fee is. So what's the one-time fee? It's our y-intercept or our initial value. So our initial value is 10. So that would be our one-time fee. Does that make sense? Thumbs up, yes. Clap if no. Did I lose you? Okay. I'm assuming yes. Okay. Last step, put these two guys together. This is my slope. This is my y-intercept. I want to write an expression for the cost of the function. So I know it says expression, but it doesn't matter. I'm just going to write the equation anyways. So y equals, that's not equals. And it's 5x because we can't forget our x. Why do we need an x here? Because it's $5 for each one of these cups. So how many cups do we have? No idea. So 5 times x. 5 times x plus 10. And actually, let me erase this 5x and let me make this in red. So you can make that connection. Yes, the 10 is my one-time fee. That's my y-intercept. That's the reason why I did it in the same color. See how that's the same color, that's the same color, that's the same color, and that's the same color. So yeah. All right. This one, it's supposed to be 5 minutes. So I will give you guys 5 minutes to try this one. We'll go in and out of your stuff. But again, if you guys get stuck, either send us a quick message or write on your paper. So when we get to you, we can just look to see, oh, okay, you know, we need to do something. So I'm going to pause Zoom or YouTube. Okay, YouTube. So make sure when you're doing yours, you're noticing mine went by tens. So that's why I said 10, 15, 20, 20, 10, 20, 30, 40, 50. Yours on your side is not going by tens. What's it going by? It's going by 50s. All right. And unlike I was able to use the y-axis, you are not able to use the y-axis.
Yeah.
So you're going to have to find a spot here that's the same. So I think this is the only extra spot. All right. Okay. Pausing for YouTube again. Zoom. So I apologize. I made this super mean. I'm about to do like help you guys on it because this was mean. So I apologize. So this is 150. This is a positive because we're going up. Then let's do green. I'm gonna go 1, 2, 3, 4, 5. These are by tens. So this is by 50. It's again another positive because I moved those pieces because I'm going to the right. So remember, rise, overrun. Some of you guys put your numbers backwards. So I rose 150. I ran 50. So how many times does 50 go into 150? Goes in 3 times. And I'm gonna put this on the side because some of you guys actually wrote right here. Now, what I could do, and again, this was mean, I apologize, but my slope is 3, which means that each one of these, I think it's cases, like cell phone cases, each one of these cases is $3. So what's 3 times 10? 30. So if 3 times 10 is 30, what is that one-time cost? I do 50 minus 30.
20.
Yeah. So then my one-time design fee is $20. So again, super mean. I so apologize. This was not supposed to have gone by by 50s. It was supposed to have gone by 10s, and I just didn't pay attention, and I apologize. So then what should this be? It should be y equals 3x plus 20. That's what it should be. So some of you guys wrote 50 because you were like, oh, there's that 50. It's not going to be by 150. It's not going to be mean. It's not going to be mean. I promise, I promise, I promise. It's not going to be mean. It will go by tens.
Yeah, it'll be just like the one we did on the other page.
Yeah, it'll be like this. It will not be like this. Again, this shouldn't have happened. I was supposed to have gone by tens, but when I created it in Desmos, it like, I didn't even pay attention that it like reverted itself back to 50 when I told it not to. So does this now make sense?
Zoom out.
Yeah, I probably like hit zoom out at like the very last second.
Mm-hmm.
So that's the end of this question. So technically for YouTube land, I gave you guys the answer to that one. Technically for third period, I also gave it to you guys. And I think Ms. Gomez is going to give it to you the other period.
Yeah,
I
I'm
don't know.
writing it down.
Yeah. All right. All right. So do we feel okay with this? As long as it it looks like this. As long as it looks like this, are we good? Like thumbs up. I didn't lose you guys. We're good. Yes. Awesome. Okay. So this one should be very, 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 oh my goodness, easy. This is just solving. It's just like 2 steps. Simple, easy, nothing to really do. Again, I want to get this x all by itself. So I need to get rid of this +2. I have a positive. So what do? I subtract 2 from both sides. My 2's go away. I'm left with -6x equals a negative, and a negative gives me a negative. I owe you 16. I owe you another 2. So how much do I owe you now? I owe you 18. Divide both of these by a -6. My -6's go away, and I'm left with x equals what? 6 goes into 8 3 times, but I have 2 negatives, so that's my answer right there. Just a +3. Super, super, super easy. Super easy. All right, your turn. I'm gonna pause the video, and you guys should do the one underneath. So I didn't really see too many problems. Some people, and I'm just gonna write it real quick on here, and then take it off so that you guys can see. Some people were forgetting to do -3 to both sides. So then you accidentally added instead. Others, you guys forgot to do, bring down a -2 instead, and you brought up +2. So that ends up changing your answer. So again, be careful with those negatives. Always double check that you wrote it down correctly. But other than that, you guys seemed really good with this. So again, your negatives, always, always, always double check and make sure that you guys have actually written it down correctly. All right, we're switching over to page 14. Be careful. This is saying solve for, and it says solve for y. So then I am not solving for x. I am solving for y only. And actually, let me change that to red so that really catches your eye. So it is us solving for y. So this is kind of like me making this into slope intercept form. So we've done that already. So we need to get the y all by itself, which means I need to get rid of this +3x. What's the opposite of a +3x? -3x. So I'm going to subtract 3x from both sides. So my 3x's go away. I'm left with -4y equals. Now, some of you guys want to subtract this and you guys can't. This 8 does not have an x. This one does. So I can't actually combine them, but I need to have the 3x in front. And then it's my 8. Why? Because my formula is y equals mx plus b. So the mx needs to go first, and then the b. From here, there's still this negative. I still need to get the y by itself. So I need to get rid of this -4. How do I do that? By dividing each one of these by a -4. So my -4s go away. Now I finally have y by itself. A negative and a negative gives me a positive, so I don't need anything. Then I have to see, can I simplify the 3 and the 4? No. So I'm gonna leave it alone. 3/4. X, don't forget that X, some of you guys do. A positive divided by a negative, that's gonna change. That's gonna be a negative. And 4 goes into 8 2 times. So that one could be fixed. So what's my equation? 3/4 x minus 2. Okay. So I'll give you guys another 3 minutes on this one. So I'm gonna pause the video, resume. So a couple of things, guys, that I'm noticing for your equation, and I'll bring it down here because some of you guys are getting a little bit on the confused side. Yeah, some of you guys are very confused and other of you guys are like, no, this is actually pretty easy. So again, we're trying to solve for y. So we need to move the 5x, which all of you guys were able to do that. No confusion on that one this time. So you guys all caught on to that. The 5x's go away. I'm left with negative 2y equals, and again, I can't combine these guys, so I need to put them side by side. Some of you guys are still not putting the x first. It should be negative 5x plus 6 in that order. The 6 should not be in front of the x. From here, this is the part that some of you guys messed up on. Some of you guys knew to like divide, and then somehow this 2 like either turned into like a 4 or a, like my 2's ended up changing for some of you guys as you were writing them. So make sure that all of these are 2's. That's the reason why I always change colors, guys, so that I can see all of that matches. All of it should always match.
Also, really quickly, see how on this equation we have equals 6? Some of you wrote equals 8. That 8 is from the other equation that we did.
Yeah, you guys do that a lot. Like you'll use the numbers from our examples. Be careful because you guys can use your notes for your final. If you guys are doing like looking at your notes, some of you guys have a tendency of writing your example on your test, and then all of a sudden you solve the example, not the test, or you're mixing and choosing. No. Be careful, focus, okay? So, my 2's go away. All of you guys are in agreement that that's that. Some of you guys, again, are simplifying this correctly. Some of you guys are not. You guys say, okay, 2 goes into 6 3 times. The negative may or may not be there for some of you guys, but it should, because that's a positive and that's a negative, should be a -3. This is the part that's freaking you guys out. Some of you guys are just going 5x because you're seeing that this ended up being, I don't know what you guys are doing. But I have a negative here and a negative here. So that means this is going to be a positive. Can 2 go into 5? No. I mean, it can, but not evenly. So we're just going to leave it alone. We're not going to do anything with that. So what's our equation? Y equals 5/2x minus 3. Do you guys see your mistakes? Are you not confused anymore?
So the fraction will turn positive?
Yes, because I have this negative here and this negative here. A negative divided by a negative gives me positive. If I borrow, that's different. But if I'm dividing or multiplying, then we do the negative times the negative gives me a positive. Less confused? Okay. All right, let's switch over to question 15. We're almost done, guys. All right. So notice here, unfortunately, you know that question that we just did, you're gonna have to do it twice because we need to solve both of these so that we can write our equation. Or we can try and solve this by substitution. If you want to solve by substitution, I would probably subtract this x, and I can make this into y equals negative x plus 5. And I can substitute this into my y. And I'm going to write this for substitution. You enjoy substitution? I like substitution. Some of you guys don't like substitution. For substitution, you would do this. All right. And I will do the rest of, I'll actually solve it for substitution first. So what would I get? And then I will graph it. So we'll do both. So I'll show you substitution and then I'll show you graphing. And let me make my text a little bit bigger. So 3x didn't change. Minus 4. And then I'm going to change the color so that you guys can see this. Parentheses, negative x plus 5, oh, not 5. Change it back. Equals 1. If we are doing substitution, this is what we would do. Again, we need to solve this for the y. And the only reason why we're solving it for y, because we technically could have solved it for x, is that, oh no, we want to solve it for x. Ms. Gomez, you're not helping me. Kidding. I'm gonna okay, YouTube, I need you to pretend that the last 10 seconds didn't happen. You guys, you too. So we don't want, and the reason why we don't want to solve for y, notice here, it just wants us to, it wants us to solve just for the y y coordinate. I just want the y. I don't want the x. I don't want both. I don't want where does it intersect. I just want where the y is. So that's the reason why substitution is better for this one, because I just need to do the work. But I mean, if you want to graph it, you guys can. So I actually want to solve for x on this one, because whatever I solve for, then it's going to give me an equation with all the other ones, like all the other variables. So I'm going to get rid of this y. So subtract y from both sides. And I get x equals negative y plus 5. So almost the same as what we had before, only this time, it's just that I have a y instead of an x. So this time, I'm going to substitute that x. So I'm going to take all of this, and I'm going to go, wee, I'm going to plug it into this x right here. That means that all of my variables are just going to be y's. So 3, oops. Now I change it back to the y, so the red, negative y plus 5 minus 4y equals 1. So notice now I have all y's, so that would help me out here. If I wanted x's, why isn't it 5y? Because I'm subtracting y from both sides. So 5 minus y, I can't do that. It would be right next to each other. Does that make sense? So again, I can't simplify, like, I can't, when I have 5 minus y, the 5 doesn't have a y, so I can't simplify them. All right. So we're gonna distribute 3 times a negative y. Now I can combine them and get, you know, negative 3y because I'm multiplying. This was adding and subtracting. I can't do that. And then 3 times a positive 5, 3 times 5 gives me a positive 15. And then I bring down my negative 4y equals 1. I'm going to combine my like terms. So I have a negative 3y and I have a negative 4y. Both of those are negative. So I know I'm going to keep that negative because I owe you $3. I owe you another $4. So now I owe you 7. Nothing happened to this 15, so I'm going to bring it down. Equals 1. Simplify this some more. Subtract 15 from both sides. Subtract 15 from both sides. And I get negative 7y. My 15s go away. Equals, again, this I can combine. So I have $1, but I want to spend 15. How much more money do I need? I need $14. Because 15 minus 1 is 14. And then last but not least, divide both of these by a negative 7. Be careful. And I get y equals 7 goes into 14 2 times, and both of them are negative, so it's just going to be a positive. So A would be my answer.
Doc,
Yeah.
so when you did 5 minus y, the 5 is just still gonna stay positive, like nothing's gonna change?
No, nothing's going to change because we're not multiplying it by a negative y. We're just trying to subtract it, but since we can't subtract it, then it's just going to hang out. Kind of like when we did this one, like the 8, nothing happens to it. It just comes down. Same thing here. Nothing happens to these guys. It just comes down. So this would all be for substitution. So all of this right here is substitution.
If you ask me, that's more work than graphing them.
So that's substitution. We can graph it now. So for graphing, no. And then I'm going to write those 2 equations all over again, and I will do 3x minus 4y equals 1. And then I'm going to extend, and then I'm going to write the other one. X plus y equals 5. So for graphing, we need to make both of these look like slope-intercept form. So again, we need to make it look like y equals mx plus b. So for this one, let me zoom in on that side. I need to get rid of that x, kind of like what we did that first time when I was making that mistake. And I get y equals, again, I can't do anything with that guy, so I'm going to have negative x plus 5. So my slope equals negative 1 over 1. And then my y-intercept is going to give me 5. So do you have to do both ways? No, just one. So this is for substitution, and I'm going to do for graphing, and then you guys can choose which way you guys want to do it. Again, for the second one, I still need to get that y all by itself. So I need to, let me do this in a different color. Red. I'm gonna get rid of this 3x by subtracting 3x from both sides. I still feel like I need to zoom in. My 3x's go away. I'm left with negative 4y equals. Again, I can't do anything with these guys. Even if this was a negative 3, I still needed to have an x. So I'm going to just put it side by side. Negative 3x plus 1. That 1, nothing's happening to it. And then the last step, get rid of this negative 4. So we're going to divide all of these by that negative 4. Negative 4 and negative 4. So I get y equals a negative divided by a negative gives me a positive. Can 4 go into 3 or get simplified? No. So I'm going to leave it like that. 3 over 4x. A positive divided by a negative is a negative. And this is a negative 1/4. So unfortunately, I don't like that because it's going to mess up our graph a little bit. So I'm going to graph this orange one right here. So I'm going to go back to orange. My y-intercept is at 5. Okay. And then my slope is down and 1 to the right. So down, 1 to the right, draw my point, down, 1 to the right, draw my point, down, 1 to the right, draw my point, down, over, down, over. So if I draw my line, that is this first line right here. So this line right here is that guy right there. For the red one, it's going to be a little bit trickier just because my y-intercept, so my slope equals 3 over 4. But my y-intercept is negative 1 over 4. This is going to be the trickiest part because it's basically like here. No, even less than that. Like there. So it's a little bit less than half. So then counting 1, let's see, it's 3 over 4. So it's 1, 2, 3. So somewhere like here. And then 1, 2, 3, 4. So something like that ish.
Yeah.
And then connect your dots. Make this red. And yeah, you see that my y-intercept is at 2. So I don't know if on your test it'll be this mean.
I hope not.
I hope not. I can check. No, I don't have the paper. Of course I don't have the paper. But if you like substitution, you guys could do it this way. So you have two different ways that you guys can do it. I'll give you guys like 5 minutes to try them. If there's any part that you're a little still confused on, let me know. So tiny, tiny, tiny mistakes, super like duper, like small mistakes. So I see all of you guys substituting, like you guys were like, I'm not dealing with the other stuff. No, I'm good. Thank you, Doc, but no. So let me actually solve it for you guys here. For some of you guys, again, I really want you guys to get that extra practice. So you'll see it down here at the bottom. Some of you guys like got it and you were like off by a tiny bit. So good job. So yeah. Yeah, like you just got it. All right. So again, we're looking for Y's. So since we're looking for Y's, we're going to solve for X. It's the opposite of whatever you need to solve for. So if on your test it asks you to find X, then you would solve for Y. If we're asking you to solve for Y, then you solve for X. So you always do the opposite. Again, let me zoom in. So I'm going to move this Y over because I don't care about that guy. I just want the X equals. Nothing happens to this guy. You guys did a very good job on this. Mistakes that I saw. And again, if I call out a mistake that you made, you weren't the only one. This guy solved for X. So it goes here for X. It doesn't go into the Y, it goes for the X. Some of you guys were super cute. And I want to say like every single one of you guys did this. You guys were all like 1, negative Y minus 3. I find this super cute and love, love, love the fact that you guys realize that there's a 1 in front of the X. Like the fact that you guys remember that is amazing. So super good that you guys remember that. Let me finish this off. Minus, whoops. To Y equals negative 6. So we're gonna distribute. Now, do we really need to distribute? Because this is a 1, it's gonna give me the same stuff. No, and all of you guys did distribute. So that's the reason why I'm gonna do it. I love the fact that you guys still distributed. This is beautiful. Like you guys make me so proud. Like I love the fact that you guys still distributed, even though this is technically a 1 and you didn't have to. But 1 times negative Y is a negative 3. I'm losing my sanity. Hey, so like you guys are doing fine. You guys are doing more than fine. So you guys are gonna do absolutely fantastic on your final. So good job, guys.
If I didn't put that 1, I would have been confused.
And yeah, like because you're used to that pattern. But I love the fact that you did put that, and you weren't the only one. I think like every single person that I looked at did the 1, which is great. Like I love the fact that you guys are like finally getting that there's a 1 always in front of the variable. So that's perfect. All right, here's the part that you guys started getting a little bit on the confused side. I have a negative Y and I have a negative 2Y. So I want to say most of you guys did say, oh, we need to add it. But then all of a sudden, I kind of feel like this part is where you guys went like crazy on the tiny mistakes. Because some of you guys forgot to do this as a negative, or the fact that you guys were writing these so weird that you like thought that this was a different number. So be careful on how you guys write. If you guys want to type it all, that's totally fine too. It's no big deal. But what would we do? I would see that this is a -3 and I would add 3 to both sides. I don't like how that looks. Some of you guys forgot to bring down that -3y and just brought the 3y over. Make sure that it is negative. And again, this confused you guys. Some of you guys put -2 because you guys were dividing. Like you guys are going so fast in your head. You guys need to slow down, take a breather. Because we're not going to be there to like check your little mistakes. And it's totally fine for you guys to use a calculator, okay? So -6 plus 3. I owe you $6. I gave you 3. I still owe you. But how much do I owe you? I owe you $3. All right. And again, I don't like the way that negative looks. It was looking at me funny. Finish this off by dividing by a -3 to both sides. And I get y is a +1. And notice that I gave you both positive and negative just to see if you guys were paying attention. So it should have been just C. So be careful. All right. I did resume. Okay, yeah. I was like, I did record all of that, right? All right, we're gonna switch over to 16. Get it, be careful.
Yeah, because the B was a negative, was a -1. Be careful.
Be careful. Yeah, I like it. I like it. All right. This one is kind of, it can be tricky if you don't pay attention. So what is this question asking us? Justin solve the equation 3x plus 5 equals -4x minus 2 using the following steps. So this is where we started. And this is where he got to at the very end. It wants to know at what step did Justin make a mistake and what was his mistake? All right. Okay, so a couple of things that we can do. We can start solving this ourselves. So what should we do? Well, I should probably move this 4x over to the other side. So I would probably add 4x to both sides. Or I could have also subtracted 5. No, not subtract 5. I wouldn't have subtracted 5. I would have added 2. Or subtracted 2. Or added 2 or subtract 5. There's plenty of different things. And then this should have given me 7x plus 5 equals -2. That's not what he got in for step 1. So let's look at what he got for what it says. In step 1, he should not have added -4x and -2. Because that's what it seems like he did. It looks like he added -4x and a -2 to get to -6x. That's a no-no. Okay, we can't add these two guys together. So then what was his mistake? His mistake was A, the fact that he did that piece. Does that make sense? So you can either solve it yourself or just go step by step. Instead of doing this piece, just go, okay, step 1 says he should not have added -4x and a -2. Well, did he do that? Yes, he did do that. Okay, so then that he's not supposed to do that. So then it's going to be A. Or this one, in step 2, he should have gotten 3x. So step 2 right here, he should have gotten, 3x? No. If I move this 3x over to this side, it would have given me a -9 because I have to subtract. So that's fine. And then in step 3, he should have gotten 1. No, because if I divide these, then I would end up with a fraction. Or D, there's no mistake. So go through each one of these steps and figure out where his mistake is. So this one it'll be a very, all right, back to resuming. So for the most part, you guys got this. Some of you guys didn't, but if you guys start solving this one, I mean, 2x plus 4 equals -3x minus 6. First step, get rid of this -3, add 3x to both sides. It's a horrible 3, but whatever. So I get 5x plus 4 equals -6. So what happens here? After this, we have to subtract 4 from both sides, right? So I get 5x equals -10. Is that what they got? That is not what they got. So notice B, he should have gotten -10. He got -2. So apparently my son needs to go back to 1st grade because that's not what he should have gotten.
I thought you said your husband.
Well, my husband was the first one. That's Justin. Tobias is my son. So, oh, my kitty's back there. Do you see my kitty? The kitty's right there. My son was bothering him. Her. All right. Any questions on this one? Are we good? All of you guys pretty much looked good. Awesome. Okay. And then the last one, like I said, guys, we've done this one so many times. Like, it's unreal how many times we've done this. It's like crazy. But again, think of this. The very, very, very first one that you guys should all be able to tell now is which one this belongs to. If this was A, this one was B, and this one was C, what does this one belong to? Is it A, B, or C? It's C. Because it's above the line. You see how it's moved up? So that's going to be going to C. All the other ones look exactly the same, which means that it could either be I'm dividing by 4 or I'm multiplying by 4. So think and remember, we've done an example of both of these. Dividing by 4 means that my numbers are going down, 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 down. Multiplying by 4 means that my numbers are going up, 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 up. So which ones are going up? This one's going up. Which ones are going down? This one is going down. So what are we looking for? Let me do this in purple. Looking for numbers that go down or go smaller. This one, what are we looking for? Looking for numbers that become larger. And this one, looking for a graph that moved up or down. Okay. So, bottom one is for you guys to do. I'm going one more time. I'm pausing. All right. And that's it. All right. So we've gone through each one of these. So those of you guys who will watch this later, you know, have a very good weekend. I really hope that you guys pay attention to stuff like this later. And you guys, you know, watch these, next few videos, over and over and over again. I know it's long, but whatever. I'm gonna stop recording because do you guys need anything? Are you guys confused on anything? Do you guys how do you guys feel? Ms. Gomez, you're muted.
Yeah. Keep in mind the last ones we just did right now tend to be on the harder side, but you guys did so wonderful in the first couple of ones. I think we were just a little mean towards the end and we gave you some harder equations, but they shouldn't be too bad.
Yeah, your test is not going to be that bad. Everything works out on your test.
Mm-hmm. Yeah. So if you were doing really well in the beginning from like 1 through probably 10 or 11, as far as we got, but if you were doing really well on that, be confident that you're going to do really well on the final as well.
Yeah. And then again, don't forget that you guys can come during tutoring on Monday if you want an extra hour to your test. So you get 80 minutes Monday during your test, like during your class, then you get 1 solid hour. I'm cutting it at 1 hour, or else you guys will be here until you're done with your test. Or until I kick you guys out of Zoom. So